Welcome to Easy Elim Learning Simplified. Today we are going to learn on the topic Organic Chemistry 2, and our subtopic will be alkanoic acids and their chemical properties. My name is Ruth. So previously we looked at the physical properties of alkanoic acids and also how they are prepared in the laboratory. So today our focus will be now what are some of the chemical properties, or how does alkanoic acids react with other substances. You note that some of these reactions are quite similar with what we have discussed with in alcohols, but that's the beauty with alcohols and alkanoic acid. They share some of their reactions. So one of the properties is reaction with carbonates. So before we go to the reaction with carbonates, it is important for us to note that this is an acid. So when you put it in water, it's going to dissociate to form hydrogen ions, but it's usually considered as some of the weak acids because they do not dissociate fully. So for example, if I take an example of a general carboxylic acid, so if you add this in water, what happens? The carboxylic acid is going to dissociate such that it just dissociates to release only one hydrogen ion in solution. Remember, this acid has other hydrogen atoms in the structure, but only one of them is dissociated. So we say it dissociates partially. That's the reason why it's a very weak acid. So, but that does not mean it's not an acid. So you notice most of its reactions, it's behaving like a typical acid, the way an acid would behave like. Although the naming will be a bit different in regards to how it reacts as a typical acid. So keep that in mind as we see some of the properties of the carboxylic acids. So when we come to the reaction with carbonates, automatically we know acids react with carbonates to form salt, water, and carbon dioxide. So a colorless gas will be given off, which when you bubble in lime water will form a white precipitate. So, and the product that we form is usually referred to as alkanoid. So ethanoic acid, for example, will react with sodium carbonate to form sodium ethanoate and water with the liberation of carbon dioxide. If you are paying close attention, we mentioned this alkanoid in organic 1, especially in the preparation of alkanes. Go back and check that out. We used alkanoids to prepare alkanes. So you can go and see how that reaction occurred. So you see there's some interrelationship between these reactions and across the organic chemistry. So if you're able to see those interrelationships, it becomes easier for you to recall. So if you look at the equation, you can see sodium carbonate reacting with ethanoic acid. So it's only the hydrogen that is replaced by the sodium, as you can see, because we said only the hydrogen ion is dissociated in solution. So it will form sodium ethanoate, carbon dioxide, and water. Also, alkanoic acids react with metal hydroxide like a normal acid to form salt and water, which is a neutralization reaction. So alkanos neutralize alkalis like sodium hydroxide and forms a salt and water only. So for example, if you react sodium hydroxide with ethanoic acid, remember again, there is that displacement that happens. So sodium displaces hydrogen in the acid to form sodium ethanoate, note the name, and water is given off. If you were to use potassium hydroxide, which is also another alkali, with methanoic acid, for example, so the potassium is going to displace the hydrogen in the acid to form now potassium, methanoate, and water. So this is a typical neutralization reaction. So alkanoic acids as well react with metal oxides, and they also form salt and water like a typical acid, which is also a neutralization reaction, but the salt is referred to as alkanoid. So for example, if you react ethanoic acid with copper 2 oxide, so the copper ions displace the hydrogen ions to form copper ethanoate. Don't forget to balance because the valency for copper is 2 or oxidation number. So it becomes this way. Balancing is important, then plus water. And then they also react with metal like typical acids to form salt and hydrogen gas. So the salt is one that is going to be different. It's called metal alkanoid. For example, if you react ethanoic acid with sodium metal, the sodium is going to displace the hydrogen ions in the acid to form sodium ethanoid, and hydrogen gas is given off. And we know the hydrogen gas, we are able to test that it is hydrogen gas because if you introduce a burning splint in this test tube, it's going to burn with a pop sound. If we use propanoic acid with magnesium, the magnesium displaces the hydrogen to form magnesium propanoate plus hydrogen gas. So also alkanoic acids react with alcohols in presence of a few drops of an acid and heated to produce a sweet smelling compound known as ester. So this is a repetition of what we did with alcohols, and the process is referred to as esterification. So the conditions is there needs to be the acid present but not a lot, just a few drops, and then there's warming. For example, ethanoic acid will react with ethanol to form a sweet-smelling compound of ethyl ethanoate. So ethyl reacts with ethanol in presence of the acid to form ethyl ethanoate and water. So the reaction is very slow. So it is catalyzed by the hydrogen ions from the sulfuric acid. So we did this in the alcohols and the properties of alcohols. So we can check out just one example just as a reminder. We can do one that we haven't done before. So we can use butanol and pentanoic acid. So the product will be butyl pentanoate, then plus water. So we said the alkyl part comes from the alcohol, and then the alkanoid comes from the carboxylic acid. So if we were to show that, we need 4 carbon atoms for the alcohol. Then the pentanoate, so you put the structure this side, so with 5 carbon. So the OH from the acid reacts with hydrogen from the OH from the alcohol reacts with hydrogen from the acid to form water, and then we just combine the rests. So this is the ether butyl pentanoate. So make sure you're able to practice how to form the esters because this is highly tested. So esters also react with water. So let's wrap that. So esters also react with water to form the respective alkanoic acid and alcohol. So it's referred to as an hydrolysis reaction because it happens in the presence of the acid. It's like a reverse reaction of what we have discussed. Okay, so in conclusion, some of the uses of alkanoic acids, it is used in the pharmaceutical formation medicine, especially ethanoic acid. And then it is used there in manufacture of dyes and insecticides. It's used in seasoning of food as vinegar. There's coagulation of rabalax. It's used in the preparation of polyethyl ethanyl ethanoids, which are used to make artificial fibers. Also manufacture of soap. It's used in the manufacture of perfumes, and we saw in the esters. So that brings us to the end of the lesson. So see you in the next session as we focus on soaps.